Atomicity is one of the 4 ACID properties that defines a relational database management system. And I always say relational, but really it defines any database system, whether it's NoSQL, graph, time-based, really anything. Atomicity is a very critical concept to understand. How about we jump into this lecture and discuss this beautiful concept? So talk about atomicity. Really, all the queries in a transaction must succeed. That is the definition of atomicity. We talked about what a transaction is really in the transaction lecture, and we said that all the queries in a given transaction is considered to be one unit of work, and that kind of defines what atomicity really is, right? It's like an atom, and until now, an atom cannot be split. I know there's a nuclear fission that kind of contradicts that, but that's where atomicity comes into, right? You treat this as an atom that cannot be split. All the queries in a transaction must succeed. If one query fails, what happens? If one query fails for any reason, a failed constraint, like the balance goes to minus negative, or a duplicate primary key entry, right? Or an actual invalid SQL syntax, that is a failed query. And what happens when you have one single, even if you had 100 successful queries in the same transaction, that one failure should roll back the transaction immediately. Because I said, things went wrong. That's the rule of atomicity. So what happens if the database goes down during my transaction? I can't really roll back because the database goes down. What happened in this case, if the database went down prior to a commit, you didn't really commit the transaction. All the successful queries in the transaction should be rolled back, right? Even if you had 100 successful queries in this transaction and you didn't really fail, your query didn't fail, but the database just crashed. All right, so the next query didn't really fail, so the database will restart. So once the database restarts, that's when the database should detect that, hey, there was a failure technically, right? Because my queries didn't fail, but the database went down and I was mid-transaction and I didn't commit. These changes made by the transaction, if the database is actually making changes, should be rolled back. That's why I always want you to think about this as you read this, as I talk. What is the database doing in a transaction? Is it actually writing to disk? Right? I'm not going to commit. What if I don't commit? Do we go back to disk and remove these changes? All of this thing really is what makes or breaks a database, right? And this goes back to most of the questions I receive, really, is what database should I choose? Well, really, you need to understand how these databases work, and based on your use case, make a choice. There are databases that before commits, any write you make, right, in the queries and the transaction, they are actually writing to disk. So they assume you're gonna commit, so they are optimistic in that nature. So when you actually in fact commit, I don't need to do any work because I committed. I actually wrote everything to disk. It will just write one bit that says this transaction is committed, and it's so fast, right? Other databases don't write anything, so the queries are so fast executing because they always write to memory. But the moment you want to commit, they have to go take everything that is in memory and then flushes to disk, and the commit will be slow in that regard, but the rollback will be as absolutely fast. You know, it all depends. There is no right or wrong. There's always a trade-off. Let's take an example. This is an example I talk about in my transaction lecture. Atomicity. So I have the same table, account table, balance 1,500, account ID 12. We want to send money from $100 from account 1 to account 2. What do? Very simple. We need to debit this account and credit this account. So minus 100 this, plus 100 this. And we have to do it in a transaction because these two should happen at the same time, right? So we start a transaction. We select the balance to check if this guy even have money. And they do, because the balance is greater than 100, because it's 1,000, right? Because that's the account 1. So yeah, let's go ahead and update the account. Let's deduct 100 and what? Database crashed. I did one change, and the second change I wanted to do, but the database crashed. We restarted the database. And let's assume this is a badly implemented database system. This is what we see when we restart the system. We see 900 here. What happened? So in this case, we just lost $100 in thin air. Right? That's really bad. That's really bad. Inconsistent. This is an inconsistent view. Not only you just lost actual money, that you have no idea where it gone because of technology, effectively, right? So after we restarted the machine, the first account has been debited, but the other account has not been credited. Very bad, inconsistent view. So lack of atomicity leads to inconsistencies, and we're going to talk about consistencies in its own lecture. This is really bad. We just lost data. The information is inconsistent. We talked about that. An atomic transaction is a transaction that will roll back all the queries if one or more queries fail. Well, in this situation, yeah, there is a failure, but it's not really our fault, because my other query, didn't even execute. So the database got restored. So how do I know to roll back? I don't know. The database didn't even give it a chance to roll back. I can issue the command rollback. So the database now is responsible to clean up this garbage. It will say, okay, there was a running transaction, and it has to know that there is a transaction that has been running and it was crashed, right? So upon restart, we need to clean up, right? And let me tell you, from my professional experience, right? I started working professionally back in 2005, and I've seen rollback that takes an hour, over an hour actually, for long transactions, especially in SQL Server. But I've seen rollbacks, not actual rollback commit by the user. No, actually the database says, wait, I can't even start the database before I roll back this stuff, because it has to go and clean up all the garbage that has been written, this half garbage that has been written, right? And this is the garbage has been written here. So we wrote that debit one account minus 100. We need to change the 900 back to 1,000 to get a consistent view. And that's where it all play. Some databases won't let you start the database before it's rolled back. They in recent patches and recent releases, they'll say, okay, it's not really that bad. Let them roll back. Let them continue working on other tables, other databases. But this database now is it's in a rollback state. So CPU is getting hammered, right? Memory is getting hammered. All these things really as a result. The database should clean this up after a start. We talked about this, and we talked about how long this could take, right? And it really depends on how much you wrote and how long was the transaction. Long in transactions is generally a bad idea because of these things. Let's do a quick summary on atomicity. Atomicity is the idea of the transaction being one unit of work and that cannot be split. That's the property of an atom, at least back in 1970. If they figure fission, nuclear fission, then this is broken effectively. But you get the idea, right? So you cannot really an atom should be one unit and cannot be split, right? So if you have a transaction with 100 queries, all these 100 queries should succeed. If any of these 100 queries fail, all the 100 or anything that is successful in the query should be rolled back. And not only that, but you should, even in the case of a crash in the database, so that's not an actual explicit failure by the user, that should also roll back the changes. That was the Atomicity lecture. I'm going to see you in the next lecture. Stay Stay tuned.